In the previous video, we created the TNT part, and now I need to add in all the various models necessary to get the part to act like a chunk of TNT and blow up. So the all of those end up being added through the model button and keyword manager. So click on that, and it opens up. And at the moment, there are only three keywords: the element keyword, the node keyword, and the part keyword. The elements are all the various elements here. That's an element. And then the nodes are the nodes. The nodes are going to be the intersecting points. And then the part is the one part we have, which is TNT. So I need to add in quite a few things to get it to run. And well, let me start here. The first thing I'm going to do is I'm going to click on the All button so I can get it to the other uh, model options. And I'm going to add in a control for the termination. So I need to end the run of this model at some point in time. And for this model, it's going to be in, we're going to run in units of centimeters and microseconds and megabar. So I'm going to enter all the units in like that. And that kind of is a traditional unit system when you're doing HE shock. Oh, that was contact. Let me model all, collapse all. Sorry, I hit the wrong one. I need to go into control and then termination. Scroll down, double click it, and this is going to be in microseconds. Our HE moves at about a centimeter per microsecond, and it was what, 10 centimeters long. So 10 centimeters, it will, if we light it down here, burn all the way up to here. So let's go maybe a little bit more. Let's maybe go 20 microseconds. So let me hit 20, click accept, and then done. And if I go to model, we now have a new keyword, control termination. So let's just keep adding them. One of the other things I want to do is I want to have some stuff available to view after the model's done. So that's a keyword. Go to all again, collapse all to make it easier. This is going to be a database. So everything that we want to view is hidden under the database options. And binary D3 plot is the most commonly used one. So I always want to add that in. And the only option I need to set here on this particular keyword is the DT, how frequently to save the variable dumps. So if we're running at 20 microseconds, let's say if we did a DT of 1 microsecond, that would give us 20 different time steps to look at. And that's going to be probably plenty for this. I don't want too many. They can be really quite big. So I want to make it reasonable. So 20 is not going to be too bad. Hit accept, done, go to model, and now we have the database binary D3 plot added. Um, Let me go back to all, and let's see a few things more that need to get added. The collapse all here. The materials actually need to behave like they're supposed to. So in this case, TNT needs to behave like TNT. That means I need to add in some kind of equation of state that says, okay, this is the way that this thing works, and some information available on the detonation, how fast it goes, where we should light it. So let me add in first the equation of state. And for this, I'm going to use a JWL. So JWL is kind of a traditional form of EOS for explosives. It's a pretty easy to calibrate set. It works well, so people like to use it. And you can look around and find JWLs for all kinds of explosives out there. So in this case, I'm going to give it a title, TNT underscore JWL. And I need to add in a new EOS ID. This is going to be referred to a little bit later when we have to assign the part to the EOS, or the EOS to the part. And then I need to add in the parameters for the JWL. And the JWL consists of A, B, R1, R2, and this omega, and E naught are the parameters we need to use. V naught is going to be the initial volume of the HE, which we almost always take to be 1. So the calibration set of for TNT here, let me go over to my database, and let's see, is going to be a parameter. Dadgummit. Let's see which one's A. There it is. So A is 3.712, and you can look up a JWL. It's a fairly easy functional form. It'll tell you what these parameters actually do. 0.03231 is B. R1 is 4.15. R2 is 0.95. Omega is going to be 0.30, and E naught value is 0.07. And like I said, you can go look up the JWL functional form, and you'll see what these values actually correspond to, and you can plot out what the EOS looks like in pressure space if you want. But anyway, I've got this in now. I'm going to hit accept. So the keyword is now in. I'm going to click done. And if I go back to my model, EOS JWL is available. So the EOS just sort of says how the energy is available. It doesn't give it more information in it about how fast it should detonate and where it should light. So I actually need two more components to tell LS-DYNA how TNT works. And so one of them is going to be a material. And so under the mat, all, collapse all, if I go to mat, mat has a lot of options for making materials behave like a material is supposed to behave. So if you look, there's elastic. So if you have something that's elastic, it's there. Plastic, kinematic, and there are just hundreds of options to make a material behave the way you want it. And so much of doing a keyword input for a model is filling out the various mat properties that you need, and periodically an EOS is associated with it. So here we have mat property 008, high explosive burn. So if I double click it, I'm going to give this a title, TNT. I'm going to call it detonation property. It doesn't really matter what you call it, just as long as it triggers something in your mind when you see it. It needs a new material ID, which, because we don't have one, is now 1. And so I need to set these three parameters. This is going to be the density of TNT. This is the detonation velocity, and this is the CJ pressure. The CJ pressure for an explosive really means the peak pressure that the explosive develops on detonation. And when you look at an explosive when it detonates, you have this very, very sharp shock front. It reaches a peak. That's PCJ, and PCJ stands for the Chapman-Jouguet pressure. You can look up what the Chapman-Jouguet pressure means, but that is effectively the peak pressure that the explosive is going to detonate. And so let me add this in. TNT's density is 1.630 grams per centimeter cubed. The detonation velocity is in this case, centimeters per microsecond, 0.693 centimeters per microsecond. And the CJ pressure, this is in megabar, is 0.21 megabar, 21 GPa. The other values I don't need to set, so I can just hit accept. Now that's in. If I hit done and look at my model, my mat, high explosive burn is in. So we've got much of what we need for the explosive defined, and I need to add in where I'm going to light it. So let's go all. Where, that's an initial condition. And so if I look at initial, these are a lot of initial conditions you can set. Velocities are on here, stresses and strains. So this would be at time 0, what is the condition that you want to impart on it? And in this case, we want a detonation. So I'm going to double click that. And I need to fill this out. So if you remember, the part was between 0 and 2 centimeters in X and 0 and 10 centimeters in Y. Let's detonate it. Let's detonate it somewhere down here at the bottom at about 1 on X, Y of 0. Let's see. Part ID I need to pick the part ID of the material I want to detonate. Um, that is, in this case, we only have one part, and if you remember, our part ID is right there, 1. So I'm going to set that to 1. If I had a bunch of parts and the actual HE that I wanted to detonate, its part number was 10, I would set that to 10. Here it's easy because we only have one, but you have to set the part ID, and let's see, that is it. This is a light time. You can use that to change it if you don't want it to start at 0. If you wanted to let the model run for a little bit and then light it, you could add some time there. So let me hit accept. And our detonation is in, and I think detonation, if I click here, uh, it will at least tell me that it's there. Sometimes it'll show it down here. It's not right now. But there we go. So that's in. I really only need to do two more things. One, I've got to tell it how to treat these elements. So let me collapse that. And so these elements, if you remember, they're 2D. They're not 3D. And that is going to be under section. And generally, if it's a 2D part, it's going to be a shell. That's the one I'm going to use for this particular model. If it's a 3D part, it's a solid. So these are the two that I use most frequently. There are other options in here that can be used for other types of models, but for this particular one, it's going to be shell. So let me double click it. And here are a couple of things to consider on our shell. I'm going to call the title just 2D shell. I'm going to give it a new section ID. And the thing that needs to be considered is right here under element form. Down here is a list of all the various element forms you can use to model that. In this particular case, probably something along the lines of 12, 13, 14, 15 are going to be the ones we want to consider right now. But you can see there are a lot of different shell elements depending on what it is you're trying to do. If we go with 12 and 13, it's going to create or treat it like just a 2D Cartesian volume, I guess. It's not actually a volume. It's a 2D Cartesian surface. So what you see here is exactly what's going to be modeled. If we do 14 or 15, and maybe we'll do 14 or 15, this is going to create this as an axis of symmetry, and the way it will think of the problem is it's going to spin this about that axis of symmetry, and so it's going to be a cylindrical treatment. And many times in a lot of what we do, we have an axis of symmetry, and so we treat it as a 2D axisymmetric. So maybe in this case, I will just do a 2D axisymmetric. Let's see, either 14 or 15. Let's just do 15. If you want to play around, maybe you're at 2D axisymmetric. Then whenever you are done with that, come back and then change it to 12 or 13. So let's set this at 15. And I don't need to set anything else. Let me just accept. Done. Okay, so that is in. And then the absolute final thing I need to do is I've got to go to the part and assign to the part the various material options, EOS's, shell options. So collapse all, part. In fact, I need to go to model because I'm not going to add in a card. It's already there. Part. Let me add it in here. And this is for my TNT. And so I need to assign the various options that we put in for material models to the actual TNT part, so it knows it's TNT. So part ID is 1. Section ID here, that tells us how we're going to treat it. That's what we just set a second ago. That was our 2D section. If I click on this little, press the button to select from a linked table, there's that 2D shell that we just created. So I want it to be treated like that. At the moment, it's going to be axisymmetric, 2D axisymmetric. Material ID, if I click on that, there's our TNT detonation property. Okay. If I go into EOS ID, then it's a TNT JWL. So let me double click that and it's done. The only other thing I'm probably going to set here would be the hourglass. And the hourglass helps deal with heavily distorted zones. And I've have not created an hourglass keyword yet. So I could go to the keyword manager here that we were using right back here and create it, or because I don't have it created, I can create it here. I can click on uh, uh, the hourglass ID option. It says we don't have one available. Do we want to create a new one? And if I click the new keyword, it'll bring up the keyword manager under the hourglass option, and I can just add it. Here I'm just going to call it hourglass. I can get a new hourglass ID. I'm just going to use the default options that LS-DYNA chooses. Hit accept. And you can see now it's added in my hourglass ID keyword to this box. And if I look, I need nothing else. And so if I hit accept and then done, let me look at my model. Expand all to see if I've got everything I want. So I've got my control. I've got when I want to stop. I've got the database, which tells me what options I want to save. And under database, they're a pre-populated set of default values that usually work. So usually you don't have to specify any other additional parameters. Element shell is created when we made the mesh. EOS, we add our JWL hourglasses in. Detonation, we put the location. The mat is our high explosive burn. Node was generated by the 2D mesher. Part we just set, and then shell we've done. And so with that, the keywords are now done. And I can move on to running the model and then analyzing the results, which I will do in a separate video.